Okay, the next one. Estimate the force required to accelerate a 1,000 kilogram car at 5 meters per second squared. And then if the same force were applied to a 200 gram apple, what would be the acceleration of the apple? So the first part, how do I calculate the force required to accelerate 1,000 kilograms at 5 meters per second squared? Yes. So Newton's second law, force is equal to mass times acceleration. I will leave the summation sign off because we're dealing with just one force in this case. I should point out to you, I neglected to mention last week that Newton did not write it this way. He actually wrote it differently, and I will show you that later when we study the concept of momentum. But it's equivalent mathematically. So in our case, the mass is how much? 1,000 newtons, okay? The acceleration is? So that means the force is how much? 5,000 what? Newtons, okay? So that's the first part. Now, if I use the same force, so 5,000 equals, and what is my new mass?
200.
And what would that be in kilograms?
Wait. 2,000?
200,000.
Wait, which one? 200 grams into kilograms. 200 grams? 200,000.
Going the wrong way.
Oh. 0.2.
Yeah, 0.2. Times A. Alright, just so happens that 0.2 is the same as 1/5, so when you bring this to the other side, that turns out to be times 5. So 25,000 meters per second squared. Now, lest you think that's not possible, it is. You can certainly come up with forces like that, or accelerations. They won't last long, but they are possible. That, by the way, would be the equivalent of about 2,500 times the force of gravity. Say 2,500 Gs. If a human were subjected to that, you would be crushed. The apple probably as well. All right.
What's the pressure in the ocean? Deepest pressure of the ocean where you start to feel like a crushing. Is that negative G's or G's?
Pressure is different. You actually, it turns out that you cannot breathe underwater. In other words, if you were to run just a tube up to the surface, you cannot breathe when you are more than 5 or 6 feet underwater, something like that.
Why?
Because the water pressure is too great. Your lungs will not expand. It's pretty crazy, and that's the genius of scuba equipment. It automatically adjusts the pressure of the air going into you so that it balances perfectly with the outside pressure of the water, and so you can breathe normally. If it did not do that, you either would not be able to breathe, or the pressure would be so great that you would have micro tears in your lungs. This is why when you dive, if your air supply fails and you go to surface,
Breathe out.
you always keep your mouth open and allow air to escape. If you do not, then you will have what they call an overexpansion injury. The pressure inside your lungs will cause ruptures, and it's pretty much guaranteed to kill you. It's worse than getting the bends. You can survive the bends. Overexpansion injury, most likely it'll kill you. So it's serious business in that.